Hi, welcome to Fortnite Pi videos. This is DC here. This is the third video on Mifare application directory, MAD. In this video, I'm going to show you how to create a MAD structure using Mifare Classic or 1K or Mifare Classic 4K. These are some of the highlights of what you have learned in the last videos. So sector 0 and sector 16 contain the UID, and it's also called as a MAD sector. Now reading the MAD sector tells the different applications stored in the card. So this is used by the terminal software. Say for example, the terminal software can first read the content of the MAD sector and look for application ID with the 03 and 07, and if the application ID is present, it can take some necessary action or it can throw this as an error. So to put in simple words, any terminal reader, any terminal software, so this is the reader, the first thing it should do is read out the value of the MAD sector, that's the sector 0, and we know that sector 0 contains the list of all the applications that are present in the card. Now each application has got a unique ID, so if the software finds an application ID, so it confirms that it is reading or writing to a known tag. In other words, if the application ID is not present, then the software can treat the card as an invalid card. And we also know from the last videos, the public read key is very much used. This is used to read the MAD sector, and the value of the public key is A0, A1 up to A5. Now this is the public key A. Mifare classic tags, they have two keys, A and B. So the public key of A, or A is called as a public key, has a value A0 to A5. Whereas the key B is not as a public key. It is known only to the reader or the system. The key B is used to modify the MAD sectors or modify any other sectors. So the documentation does not specify any specific value for key B. The value of key B is known only to the card issuer. So before we start using formatting the card, these are some of the terminologies. Again, this is a refreshing on what we already seen in the previous videos. So we have come across, in fact we come across what is called as the CRC. Now CRC is a very common thing you find in various devices. This is a way to check the integrity of the data. Now the CRC, in this case, the CRC is used to check the integrity of the MAD sector. It's like a checksum, and the CRC must be updated whenever the MAD sector is modified, and before accepting the MAD formatted card, the CRC has to be verified as well. So there is a nice algorithm which I'm going to show in the later part of the videos, which can be implemented to generate the CRC or verify the CRC. And to keep in mind, whenever the MAD sector, whether the MAD sector in 0 or MAD sector 16 in case of a 4K tag. So what do you mean by modification of the MAD sector? So when we change or when we store a new application ID, we are changing the content of the MAD sector. So every time it is changed, the value of the CRC needs recomputing and storing here. There is also a byte called Infobyte. This byte is used to identify get the information about who the card distributor or the card issuer. And again, all these are part of the standard, so it is not, there's no rule that says a card must always have the info byte. So info byte, which is in the second byte of the match sector, so this will give you the sector number where one can find the information about the card issuer. It could be name of the company, the address or telephone number. So this can be used by some new service providers to contact, and this can be used for various other business purpose as well. One more important terminology is the GPB, called general purpose byte. Now this is stored, this is part of the sector trailer, and this GPB tells you whether the card has got a MAD0 or MAD1. This basically tells you whether the card is using 16 sectors or the 39 sectors, the 4K. It also tells you what kind of format is this, whether it's whether the MAD is present itself, or whether it's a mono application or a multi application. So all the information is encoded in the GPB, which also is clearly mentioned in the documentation, which I'm going to show you in the later part of this video. The GPB is used only in sector 0, and it is not used in sector 16. So sector 16 GPB can be initialized to all zeros. The other thing you need to be aware of is called application ID. This is what the MAD format, MAD structure is used for. So this is a 16-byte number which has got two parts, the function cluster code and the predefined, or this is a predefined group ID, and it has got what's called as the application code, which is user defined. So this is the structure, as you can see here. This is a 16-bit value. The first part is the cluster code or a group code, and second part is the application code. The group code is most often taken from the documentation or from the standard. The group code tells you what type of card this belongs to. It could be transport, it could be health service, or a ski ticketing, or access control, or it could be traffic, it could be railway service. There are so many things, you can pick one from the documentation. And if you go to this Annex C, so these are some of the functional codes which are mentioned here. Say for example, if you want to adopt this standard, assume that you are creating your own a campus-wide transporting ticket. You can use the function or cluster code as 12, and you can use the other byte as any other value you like. So likewise, there are so many predefined codes here. So I've got an example here. So 1201. So 12 is the transport code. 01 is customer defined. You can put any number here, and 01 could mean a campus transporting. 5002. So 50 is a skiing ticketing, and 02 could be a location. For example, it could be Pila. So this is the standard. So whether you use these codes or not is up to you. So with this background, I think we are ready to see how to create our own MAD format Mifare tags. I would advise you to go through this document a couple of times, and these are some of the things that we already discussed in my earlier part of this video. We have seen the application identifier, the CRC here, and the information byte. In the information byte, the last 6 bits will point to the sector number where the information about the card distributor is stored, and the first 2 bits. So it's here the first means the bit 6 and bit 7. It says they are not used. Now here there's an explanation about how the GPB is used. So I mentioned that GPB tells you about whether the MAD is present, whether the MAD0 is present or MAD1 is present, or whether it has got a single application or a multi application. It's all encoded in these bits here. So ADV, for example, ADV will be 0 1 for MAD version 1. It will be 1 0 if it's a MAD 2. Again, the bit MA, which is the bit 6, if that is set to 1, it says it's a multi-application card. The multiplication means there will be more service providers using this same card, or it's a single application if you're using for your in-house or if for your campus, or if for organization, so that can be considered as a mono application card. And DA bit is, this tells you whether the sector 0 has got a MAD or there's no MAD. Again, the value of the key A is a public key, which is mentioned here as A0 to A5. The one thing I've noticed in the documentation is the order in which the byte is shown starts from the right hand side. So this is the lower byte, higher byte, up to the MSB. Whereas in my software, you're going to see the lower byte on the left hand side. So the value of key B, as I mentioned before, there's no mention here, there's no default key B. It's all the issuer or the service provider. See, if it's a multi-application MAD, then you'll have more than one service providers using the same card. So every service provider can have their own value for the key B. So again, it's a very interesting document. You can keep reading that. I'll show you one place where everything is summarized into one single diagram. So here is an example on how to compute the CRC. The polynomial used is this, and the initial value is set to E3, and also there's a mention about in what order the bytes are to be considered. Here the byte 0 is a CRC. All the bytes from starting from info in the same order are sent to this algorithm, and the checksum, whatever value you get from the algorithm, is the CRC. If you scroll to page number 16, here's a nice flowchart that describes everything about the MAD. So most of the things that we already discussed. Say the sector 0 has got 4 blocks. The block 0 is the manufacturer block. You can't do anything with that. And the next 2 blocks, block 1 and block 2, this is where the MAD is stored, the directory structure is stored, or the application IDs are stored. And the sector and the block 3 is the sector trailer. This is where you find the GPB and the value of key B and the key A and the access conditions. And the GPB is again mentioned here. We saw this just now. The GPB tells you what kind of formatting is it. Then if you scroll further down, this is a structure of the first 2 blocks. You have the CRC and info block here. Now here it goes in pairs. It's a 2 bytes block. The first 2 bytes you will have the info and the CRC. Again here you see the LSB, the lower byte and the higher byte, followed by ID1, ID2. So you're going to have up to 15 application IDs, because you got total of 32 bytes, and you need 2 bytes for that and remaining bytes for this. And also here the info byte, it's again summarized as this consists of a pointer to the sector where you find the card publisher information. And again the structure of application IDs, we have seen this before. One thing I forgot to mention is there are some cluster code and application code that are meant for the administration purpose, some kind of a reserved application ID. Say for example, when the cluster code is 00, it is for the administration use. And these are examples. Okay, if it's all set to 00, it means the corresponding sector is free. If it's 0001, the sector is defective. And you can use these values if you want to stick with the standard. And again, probably I don't know if I mentioned that before, the position of these entries, so they point to the sector, corresponding sector number. Say for example, this is the sector 0. The next entry corresponds to this application ID 1. So this corresponds to the data stored in sector 1, and the next is the ID 2, which corresponds to sector number 2. And remember, sector number starts from sector 0, which is where you store the MAD structure, sector 1, sector 2, sector 3. Likewise, the sector 15 corresponds here. So if you find a value, for example, if you find a value here, a application ID here, so that application will be present in the sector number 11, because this is B is 11, and so these are like a pointers to the corresponding sectors. And if you scroll further down, again the same, a similar flowchart for MAD2. There's no difference, there's little difference between MAD1 and MAD2. Here I mentioned this before, in MAD2 the GPB is not used at all, set to all zeros. Otherwise everything is the same. You still have the CRC, still have the information byte, and here you got more blocks than sector 0, because here you got 3 blocks, so this points to more application. So again, you don't have to have a different application IDs here. So assume that I got application, and that application uses say 3 sectors to store the data. So I can have the same application ID here, here, as well as here. So all these, starting from 17 sector, 18 and 19, all 3 sectors corresponds to one single application. So the application ID what you put here depends on the size of the application. So depending on how much data your application needs. So probably I think we had enough background now. So let's go and try creating this MAD in a step-by-step. If you remember in my previous 2 videos, I have used a software called GoToTags, and I formatted a couple of tags. One is Mifare Classic 1K, another one is Mifare Classic 4K. So we're going to understand what exactly has happened when we use that software. So I've got here Mifare Classic 1K. This is the one I've used in my previous videos. I'm going to activate. Because I'm interested only in the sector 0, I'm not going to read the entire tag. So I'm going to choose the public key A, which is A0 to A5, authenticate, and read the sector. We just have to go through this byte by byte quickly. We know that 1-4, this is the CRC, and 0-1 is the information byte. So here it says, okay, the information about the card issuer is present in the sector 1. In fact, we're not using that at all, and that is followed by a series of 15 application IDs. These are the application IDs we got when we formatted this card. So it says 03. So the first byte is the application ID. It's if you remember the documentation. Okay, so here 03, and you got E1. So 03 is the application ID, and E1 is the cluster code. So if you see this table in the documentation, E1 means it's NFC forum tag, and so the tag has been formatted to store NFC message end of messages. I think that's the reason why the group code or cluster code is set to E1. So all 15 entries, they have been set to use E1 as a cluster group or a group code, followed by the application ID, which is 03. So it looks like the entire tag belongs to one single application, and the application ID is E1 and 03. So the next thing we want to look at is the key A. We know these are the default values, and other thing is the GPB, which is C1. So here we have made some small change in the software. So C1 means, so this is what C1 means. If you decode this into binary, so you'll end up getting all these values ticked. So C1 indicates the first thing is, just take, so C is 1 0 0 0, and 1 is 0 0 0 1. Now documentation says the last 2 bit tells you what type of format. It's set to MAD0, and the DA bit, so this bit says, so let me check that documentation again. So here the last bit in it's 11000001. So this bit corresponds to DA. Because it is set to 1, it indicates there is a match sector stored in this tag. The next thing is this corresponds to MA. If this is set to 1, it indicates it's a multiplication tag. Even though the UIDs are set to the same number, this is still showing as a multiplication. So maybe you can change the value of the application IDs. And all the remaining bits are not used. Most of these bits are RFU. So reserved for future use. Now there is a small tool here to compute the CRC of all the bytes stored here. If you hit this read mat0, this entire bytes of mat0 read here. If you hit this compute, so this algorithm which there are standard algorithms from internet. Probably I do have a reference to one of the website where you can get more information about that. So the checksum using this polynomial is 1 4. However, I noticed there's a small correction you have to do. The documentation says the initial value is set to E3, whereas if you put E3, you get a different CRC code. So if you go back to the documentation, if you go to page number 9, it explains how to compute the CRC, in what order you have to use the bytes. So for sector 0, you have to start from byte 1 up to byte 15, followed by the byte 0 of block 2 up to the last byte of block 2. And if you're finding the CRC of sector 16, that's the mat 2, you're going to use in the block 0 the byte 1 up to all the 15 bytes here, 16 bytes next, and 16 bytes. If you scroll down, this is the algorithm. The document says you have to use the initial value for the polynomial as E3, and here is a nice example as well. If you key in all the values from information that 0 1 byte, you should get the value 89. Now I do have this as a default value in the software, and which I'm going to show that you will get 89. However, you cannot use this value E3. What I found is, because if you start looping from 0 to FF, you will eventually come up with the value of the preset value to get this 89. If you convert this to binary, it's 11100011. If you reverse this, if you reverse order, you say if I put 11000 and 111111. So this is the C7, whereas this is the original value is E3. So somehow I'm not sure whether this is wrong or whether this means this is in a reverse bit order. So however, you get the correct value if you put initial value as a C7. So if I put the value E3, what the documentation says, and hit this compute, you get a different value. You get 3F. You will never get 14. If I put C7 and hit compute, you get this 14. So when you come to this software for the first time, so even before you can activate, you can go to here. This is the value that is stored. If you just put, this is the same default value. So just copy pasted this value from the documentation. If I hit compute, you get the 89. So I'm going to change the software to keep this as initial value. So I'm going to show you next the MAD1, MAD0 and MAD1 from a Mifare Classic 4K. I'm going to authenticate. So I'm going to read the MAD stored in sector 0, read, and also I'm going to read the MAD that is stored in sector 16, authenticate and read. Now these are the two MAD blocks, this MAD0, MAD1. So I notice a few differences here when you compare this to documentation. The first thing here is the value of the CRC is set to 00 here, and whereas the value of CRC is stored here. So that's one difference. again, since this is standard, so if you're using this for internal purpose, you can probably not have a say, but I would recommend to have a CRC so that you get a nice checksum for this MAD as well. So the Infobyte, the documentation says this is set to 000. It's fine, it's not used. Whereas the Gpb here, so according to documentation, this should be a different value. If you go to the section here, now this is a MAD1, so this should have a value of C2 rather than C1. So if you are formatting a 4K, so you better keep this as a C2 rather than C1. And everything here, if you see the directory entries, they're all set to E1. E1 is the NFC forum group, and 03 is any application code. So we have seen how this the card is been formatted. Now next I'm going to show you how to format from a blank card. So one last thing you need to know is the access rights for all these blocks. So you can see here we have got access rights set to 4 for the first 3 blocks and 3 for the sector traveler block. Same thing for MAD1 as well. So 4 means you can read using either key A or key B, but to modify you have to authenticate with the key B. Whereas for the sector traveler, 3 means so you can read. So here if you look at the table, there is no read options here. So you cannot read the value of key A or key B. If you try to read, you still get, see the card doesn't return an error when you try to read it. You will still get some data, but that will be all zeros. Whereas the access bits you can read, but to modify either key A or key B or access rights, you have to use the key B. But when you formatted this card with the go-to tag software, the value of key B is set to the factory, the default FFF. So I can authenticate, go to sector 0, and I'm going to authenticate with the key B, say authenticate. So authenticate successful. Probably now I can go and modify anything except the manufacturer block. I can modify any of these things. But in a real applications, you will not have this default password set FFF. So you have to, when you create your own MAD formatted tags, you have to, there's no option for us in key A. You still have to keep A0 to A5, whereas key B you can have something it's very you have to have a key which is different from FF and which has to be kept secret as well. Sometimes in real application, the values of the key B are derived from the UID. So this is called the key derivation, which is very common practice in the real application. So this video happens to be more than expected. So creating the MAD structure from the scratch, I'll be showing this in my next video. Thanks for watching.